Good morning, students. Today, under the food biotechnology, we are going to see about the food additives. And that in the last video, we have seen the food additives, acetic acid. In that continuation, we are going to see about the citric acid. So, citric acid has been widely produced as essential weak organic acid with extensive use in the pharmaceutical and food industries, and citric acid can be produced on a mass scale through two ways. One is synthetic and another one is natural method of extraction process. And the natural process involves the extraction of citric acid from the citrus plants like oranges, lime, lemon, etc. Whereas when we use a synthetic method, citric acid is produced again by two approaches. One is by the chemical approach, another one is by the biological approach. The chemical approach of citric acid synthesis by use of the enzymes. Whereas when we use a biological approach, it involves a fermentation, that is by using the microorganisms like bacteria and yeast. In the year 1922, Maillard, who was the scientist who found out the accumulation of citric acid by limiting the nutrients in the bioreactors where fermentation was carried out by the microorganism Aspergillus niger. So now we are going to see about the production process of citric acid by using the microorganism Aspergillus niger. So first, the culture medium where the microorganism grows, we have to get ready with the culture medium. And this culture medium should contain a carbohydrate and a monopotassium phosphate, water, trace elements, and this culture medium has to be maintained in the pH of 1.8 to 2. And the next step where the culture media has been sterilized. So the purpose of the sterilization is to inactivate or destroy the unwanted microorganism, and the next step to cool down the sterilization, because the sterilization we use a high temperature. So the fermenter is a vessel where we carry out the fermentation. So the fermenter has to be cooled down to 30 degrees centigrade. Once it has been cooled down, then only we have to add the microorganism Aspergillus niger. And once the microorganism has been added, the fermenter has to kept as such at the temperature of 27 to 33 degrees centigrade for 5 to 14 days for the fermentation process to take place. After this 14 days, we will be getting a fermentation broth, and that after the broth has been got, we have to add the two chemicals, that is a calcium hydroxide and sulfuric acid. Once these chemicals has been added, we get a calcium sulfate plus citric acid, and as such then we have to isolate the citric acid, and then filtration, evaporation, a vacuum container, and at last we get a citric acid crystals, and we'll see elaborately the each steps one by one. First is the raw material processing, that is making the culture medium ready, where the substrates, they contain a glucose, saccharose or a starch. In case if you are adding a substrate as a starch, the saccharification process has to be done, that is nothing but the conversion or hydrolysis of the starch into a simple compost like a glucose, and then we can use a raw sugar or a beet or canned molasses for the culture medium production. And these are all some examples like wheat straw, corn cobs, then banana waste, barley waste, and these can be used as a base, as a substrate for the culture medium. The next is a spore cultivation, that is we have added Aspergillus niger, and this Aspergillus niger has to be added in the foam formation, spore. Inoculation materials added to the fermenter in the form of spore at the start of process of fermenter. So this is a bubble column fermenter. Usually in this type of fermenter only this citric acid fermentation happens, and we use the Aspergillus niger in the form of spore. So this is a surface fermentation of the citric acid in the industries where they use a bubble column fermenter. The next step is a mycelium is separated from the broth, where the mycelium is pressed to extract any intracellular citric acid which is present in that. Then next the step is to do the filtration. The filtered broth is treated with the calcium hydroxide, then treated with the sulfuric acid in equivalent volume to obtain a citric acid, and the calcium sulfate is generated as a precipitate. So the filtration is employed to isolate the precipitate, and impure citric acid is generated by demineralizing and colorizing it with the activated carbon. So after that we have to go for the evaporation, so we get a pure crystals as such at the last. So this is a picture of citric acid where it will be in the form of crystals. So next we are going to see about applications of citric acid in the food industries, where one of the foremost application is the citric acid is used as a food additives. So citric acid are used in various forms. So one of this is the formation, the making of the ice creams. So in the ice creams manufacturing, the citric acid is being used to keep the fat globules separate. That is, they act as an emulsifier, which helps to prevent the fat from separating. So it results in the smooth texture. And in some recipes they add a citric acid in the place of a fresh lemon. And citric acid also used in the wine production as a substitute or improver, where fruits containing a little or no acidity is used in the mostly in the low cost manufacturing of wine. And next is also used in the food coloring process. So next, in the beverage industries, the citric acid is an acidulant of the choice in the food industries. That is, an acidulant helps to increase the acidity and imparts the sour taste, and it helps to preserve the food. And it used in the carbonated beverages for flavoring and buffering property. That is, buffering, it helps to regulate the acidity and allowing them to resist to have a change in the acidity, and helps to enhances the flavor. And also is used in the non-carbonated beverages as a flavoring agent. It helps to enhances the flavor, and as a preservative also they use citric acid in the beverage industry. In the dry beverage industry, where the beverages have been in the dry powder form, they use it for the flavor and for the pH control. In artificially sweetened beverages, citric acids add the bulk and the mouth feel. That it helps to stimulate the saliva flow and reduces the dry sensation, and gives the tingling sensation when we take a beverage. Next, in the canning industry, it helps to lower the pH and reduces the heat processing, prevent the enzymatic oxidation, that is a color change, helps to prevent the color change and enhances the flavor. In confection industries, the citrate, it helps to control the sugar immersion and helps in making formation of the gel, and provides a tartness and enhances the flavor. As in the form of dietary calcium supplement, the form of calcium citrate is being taken as a supplement. In jam and jelly preparation, they helps to provide the tartness and control the product pH for the optimum gelation. That is, helps to give a good gelling characteristics. And next, in the fruits and vegetable processing, it helps to inhibit the enzymatic oxidation, that is the change of color and flavor deterioration, and helps to have a good stability of the frozen foods, and that is to preserve it for a long period of time, to extend the shelf life. They use it in the frozen foods. And in cheese processing, they use it in the form of sodium citrate as an emulsifying salt to stabilize the water and oil phase of cheese and improve its texture. Then next application is in the seafood. It helps to prevent the discoloration and development of odor and flavor when it is present in the seafoods. So these are all the citric acid production and applications of citric acid in the food industries. In next video, we'll see about the lactic acid production and its application.